Hello and welcome on the first webinar of SDC Verifier for Ansys. Today we are going to see the beam buckling checks possibilities in SDC Verifier according to AISC standard. So first I would like to start with agenda. We are going to see how to get started with SDC Verifier in the Workbench. Then we will explain what is the job in SDC Verifier. This is key idea of SDC, and then we will see some tables. Then we will go to recognition of buckling length, which is required for checking our model according to AISC standard, and then we will generate the report and show what capabilities are in reporting possibilities of SDC Verifier, and in the end we will have some question session. So let's start. We have prepared two projects. One project is for demonstration how to start in Workbench, and second project is ready project in SDC Verifier with all the calculation done to make this webinar efficient and quick. So let's start. After installation of SDC Verifier, in the toolbox you can find new tab which calls code checking and reporting with item SDC Verifier. To add SDC Verifier to your project, you simply drag it and put on the model item. And when you click, SDC Verifier will start. So first thing you will see in SDC Verifier is creation of new project. You can fill in the project number and project name. Beam buckling example. In the list of below the job group box, you can see the list of solutions. It shows you a list of solutions from Ansys Mechanical. For now, I have only one solution in Mechanical, so the user has possibility to select which one solution to import. So when I press OK, my project will be created and settings of the solution will be imported. As you can see, I have here all my loads and boundary conditions imported from the solution. Job is the set of options of analysis and extra items in SDC, such as load combination, envelopes, and extra post-processing tables and plots. So I would like to give an explanation of the job and its items, because this is core idea of SDC. So what is individual load? Individual loads represent a result step from analysis of Ansys. In my Ansys model, I have analysis with 4 steps. So in results, I have 4 individual loads imported into SDC. Load set, it is a linear combination of individual loads with factors. And load group, it is envelope with worst results among loads. Load groups we use to check the maximum stresses or displacement in your model with one picture or table. So now I'm going to demonstrate how you can create the load combination. For example, first result from analysis, it is gravity. Let me show you. And for example, I have also nodal force applied at step 4. For example, if in SDC I want to combine them, I select them from the list and add to my load sets, and I can give factors. The result of individual load will be multiplied on that factor, and the results of those 2 items will be summed and form results of load sets. Usually factors should be taken from the standard. So I will use for this example 1.3 and create. I have showed you how to create one load set, but usually it's not very efficient way. We have a special tool to create few of them. So I have prepared in Excel the list of load sets with factors, so I simply copy them and go back to SDC. When I press from clipboard, I have the list imported, and I have to press OK button to create 8 load combinations. So it is possible to modify factors here or create in this table. It works like Excel tables with copy-paste possibilities. This method is a quick way of creating load combinations. And now finally I would like to create the envelope of all my load combinations. I will call it overall load sets. Create. Now we are going to close this project and jump to project I have prepared before. So we go back to Workbench and start SDC. When you save the project, when you run SDC, you have the list of files, SDC files which was saved. So I will use the demo1 final SDC file. As you can see here, I have already created few tables, and I want to show you the difference between load sets, load groups, individual loads by using a table. So this table represents reaction forces over loads. I have selected all my loads. I want to show the table on the selection of 6 nodes, 6 support nodes. That you can see in my model. So if I press fill, I have the list of my loads with reaction forces and moments over directions. As you can see, the minimum is highlighted with aqua color and maximum with red color. So worst result, for example, in X direction I have in loads 3 and 4. As you can see, load groups show me the highest absolute results among all load sets included. So that's 18, and in this case that's 13. This from load case 4. And for example, in Z direction I have highest force from load case 1. So this example demonstrates the difference. Load sets, it's summation of the forces from individual loads multiplied by factors, and load group is envelope. It looks for worst result among its items. So in my case, it's all load cases. The next table I want to show you is also about reaction forces, but it's the previous table was worst result on a selection over all 6 my support nodes, and this one will be detailed table. I have my node number 1 and all the reaction force details on that node. And also I have same behavior. It's highlights for me which is minimum and which is maximum. So all 6 nodes in my model I have through the loads. And if I'm not happy with the table, I can make it smaller by using option skip rows without maximum. So it shows me only rows where I have maximum and minimum, so I can see which loads are important. So in this example I show you reaction force, but actually we can do that for any of result category: stress, displacement, element forces, GP forces. Another type of table I would like to show is this is for one load, so I use my envelope group, and I can see the result over selections. That can be material, properties, or name selection. In my example, I have selected all properties just for demonstration. So if I press fill, I can see the stresses, the worst stresses for each property in my model. And now we are going to see the plot I will create a criteria plot for my envelope, so I will select load group, equivalent stress, and on the full model. So with this plot I can see the worst result over all load cases in my model. After job setup is complete, all load combination load groups are created, the first results are evaluated, it's time to go to standards. To perform verification according to AISC standard, we need to have the beam buckling length in 3 directions. For that, SDC Verifier has a tool which calls a beam member finder. So now we will run this tool to recognize the beam members. So you simply start it and press search button, and in a second you have all your members recognized. So I will display a plot with recognized beam length in Y direction. Now you can see that different beam members are shown with colors, and also label on the center of the beam member is shown the actual length of the member. The complicated part is that the length in 3 directions should be checked in an AISC standard in Y, Z, and torsional direction. I'm going to explain the difference with an example. For example, here we have a bottom part of our structure, and here you can see that this member is braced in that direction. So it is in local Y direction of this beam, so this joint we call 2dy joint. So if we will consider length Y, then this member will be splitted in that joint because it is braced in Y local direction of the member. If we will take in Z direction, then we can see that this member is not splitted and the length is 5. So you have different length on same elements, which makes this check complicated to perform. So with help of beam member finder you can do that automatically. Now I'm going to show with an example on one beam member what I mean. So I have beam member 9, let's preview its plot. So as you can see, in Y direction it is splitted on 2 members only with length of 5 meters. It has connection with these beams, but it is done in Z direction apparently because it's not splitted. If we go to beam member finder in Z direction and I see same beam member 9, I can see that it has 4 sub-members with length equal to 2.5. Let's see the plot. Now you can see that I have 4 sub-members splitted in this position because I have 2DZ joints. So also, besides the length, you can preview the IDs of the members you see. For example, let's plot same member and show the IDs. So you can see that we have beam member 9 and 4 sub-member 9.1, 9.2, 9.3 and 9.4. Usually you don't have to modify the length of sub-members, but in case in your model something is not taken into account, it's possible to change the length. For example, you can select here and change the length In my example, I will do 2.4. And as you can see in the table, it shows that member was modified by user, and in the event you see asterisk that gives you a reminder that length was modified, not automatically recognized. So, and if I do plot of that member, I can see that asterisk shows me that it was modified on the plot. Another feature of Beam Member Finder is I can modify the beam in all three directions at the same time. For example, let's go back to the same beam I have used before, Beam Member 9. Here I can see with a scheme how my beam member is splitted. On top I have the node numbers, which are joins, and also here they are shown in a table, and with checkbox it shows where it is splitted, where not. For example, I will take the beam member in Z direction and, for example, change this to do not split in node 1103, and it is modified, as you can see, immediately. So I have changed member 9, and in Z direction it should be one single member with length 10. If we go to member 9, it becomes one member with length 10. Let's plot. So I will go back and change how it was. The last thing I would like to show you is filter options. For example, if you have some group of members you want to change at once, you can use filter, and you can select all members on the selection, or by criteria of length. For example, if I want to see the members with length above 7, for example, in Z direction, find. This is all my lengths it found, and I can plot them. So this is picture of all members which has length above 7 meters. When all the beam members length are reviewed and effective length and everything is fine, then it's time to go to a standard. I have created already a standard, and we will use it because it is already calculated. I will show you how to add standard through the wizard. So you go to standards menu, add, and here we have the list of implemented standards and custom standard. Today we are going to review AISC 360 and 10 standard, but also we have Eurocode 3 standard, which works exactly the same as AISC standard based on beam member lengths. Also, you can use API, ISO, and NORSOC standards to check tubular members. So let's start with AISC. Wizard helps you define the additional input which is required for the standard. For example, it is necessary to define the build type for your properties. So we will set the rod type for all beams I have in my model. Also, it's possible to define the CB, lateral torsional reduction factor, for bending check. By default it is 1, but user can set that for different members, or it is possible to use our tool which can calculate CB factor based on moment ratio diagram. In addition, you have the check of yield and tensile values are not set in material to 0 because standard use those values for calculations, and wizard will notify you if you forgot to set them before. So if I press this edit button, I can see I have one material and my tensile and yield stress values are set. In addition, you can change the selection on which you want to run your calculation. Maybe you are not interested in the full model but want to check only portion of the model. So we are going to check the full model in this on this webinar. So REST options we are not going to cover in details. That can be seen in our tutorial or in help file. So after the standard is created, you can see below the complete structure of the standard. Everything which is used in calculation is here. For example, all the constant, and what is most important, that all the checks in SDC Verifier are open. What I mean, if I open the check, I can see all the formulas with comments. Usually in comment we include reference to the formula from the standard, the name. User can modify any formula and follow the full calculation procedure because everything is open. So almost all the calculations in SDC are based on this approach. So everything can be seen and can be modified. The AISC standard has 14 checks. Some of them are for calculation the shape characteristic, additional some of them to calculate the axial bending resistance. The most important checks are from 10, axial, shear, bending, torsional, and overall. Overall check is done for convenience. It contains utilization factors for all the checks that should be done in the standard. The idea is if your utilization factor, it's your result from the model divided by resistance, is below 1, then your model is past that check. I'm going to demonstrate that with a table. I have prepared two tables. One is my utilization factor, the worst utilization factor of the check among all the properties. I have selected the envelope. It means that it shows me the worst results among all my load cases for each property. So I know you can see here that property 5 and 10 does not pass the check. So I know this is one box shape and tube shape does not pass. That I have to investigate them in more detail. I have here few checks like axial bending in major and minor axis, shear and torsion checks, and combined one. And utilization factor overall, this is maximum value among all of them. So actually I have to check only this column if it's below 1 or not. I have also one more table to show. The previous one was envelope based on selection, and this one is for all the loads I have in my model on full model. So I can see which load cases gives me the worst values. I see the load case from 2 to 4 is the worst one and generates the problem in the model. For some users, it's important to change the limits. They want to have results below not 1, for example, to highlight the utilization factor, but below 0.8. I will show you how you can change that in SDC easily. So you go to your overall check, and here we have limit for highlight the values. So I will change it to 0.6, for example. And now we are going back to my table. Now you can see values which are above 0.6 is highlighted in red. So it's completely customizable, the formulas, the limits, and the type of the parameters. So when we know we have checks that do not pass, we can go and do extra investigation what in more details what loads are causing the high results. For that we have in SDC governing loads tool. I have created the tool which is based on AISC criteria. All results in my envelope will be above 1 will be selected, and it will find the governing loads for AISC result. In my example, I have two loads. I have load set 4, which has 15 elements above 1, and the highest result is on element 64 with value 1.48. For load set 3, I have 2 elements which have results higher than 1. The highest one is element 1140 with results 1.12. And I can make a plot. So I will select 2 load sets, and we can see in mechanical the elements. Green elements is load set 4. We can see the label here with green background, and on my model I can see that I have elements highlighted with green. They have governing loads load case 4, and also on top I can find 2 elements which are from load case 3. You can see here a label with orange background. I will use thickness for my plot. Maybe it's better visible where I have. So this is nice plot to preview on one picture what are the governing loads for AISC standard. The governing loads tool has also the possibility to show you detailed information about governing loads. If I use type expand and do fill, I have a list of all elements which do not pass my criteria with the results and which is governing load. This governing load is not limited to checks. It can be done for any check you have in SDC, but it also can be done for simple results as stresses or displacements. So I will use for next example stress equivalent, and for example I want to see the worst 100 elements. I will have summary fill. So I will see that the highest stresses are coming from load set 1. The highest one is on element 372 is 120 megapascal. If I want, I can make also detailed summary to see. So governing loads is for investigation of what our load cases are the most important, and also we have an option here that you can create load group including only the governing load cases and perform detailed calculation on it. The last topic of our webinar, reporting. SDC Verifier offers 2 tools to create reports, Wizard and Designer. The Wizard is step-by-step guidance, and it's better for the beginners to use the Wizard, but Designer is a real-time report generation tool with advanced features and full control over the report structure. I have prepared the result report. So how you can create the report, you can go to menu, and we have some predefined items like empty report. You have only first page and preface item, and then you have to add all the rest stuff yourself. Or model setup, this is description of your model, or results. Full type of report, it's combination of model setup and results. Model setup contains a description of your materials and properties. So I'm going to show you briefly what we have in model setup. For example, we can see here the list of materials and properties. I have 1 material and around 10 properties. So what I can generate in my report by default, this is some summary of properties. It shows me how many elements I have for each properties, what material is used, and what is the mass of that property. Same I can do for materials. For now I have only 1 material in this example, so this table is small and not that handy, but when you have the model with a lot of materials, it's much more handy to see this table. So now I would like to show you also one more example of how property description looks like. For example, we have I-beam property. On the picture you can see with red is highlighted where those elements are located in your model, and also the dimensions of your shape and all the characteristics. So the model setup can be used to check if the model was done correctly. So now we go to result report. As you saw from previous report, you can generate only parts of report. This is the big benefit. If you want to change something, for example, you have generated the table, but you are not happy with the number format or layout, or you want to change some settings, you can do only by clicking in menu generate only that portion. For example, we have generated the preface item, which is description. What version of software SDC and Ansys was used, what files was used for this project and report profile, and the time of the generation and unit system. Same we can do for first page. First page layout is actually can be customized. You can define what you want to see. It's a completely customizable page. So we created layout, you have a table look for this page, and you can configure in each row and column what you want to see. Same idea is for headers and footers. You can define the data you want to see there, and even the fonts and colors you can change. So that gives you full control over the look and layout of your report. Now I want to go to the report structure. We have job results here in this item, and then we have after that we have standard results. In the default report we have for each load it is created same results I added for each load. For example, you can see that's for individual load, and 1 and 2 I have displacement table, displacement plot, and stress plot. Same results I have for load sets, and also for each I have summary, where I have overview of stresses and displacement over all the load sets in one table. Let me show you how it looks. For example, summary, I would like to see the displacement over all my individual loads or the stresses. I can generate only those two tables. So here the important point is that you can see that the number format for those tables is different. For stresses I have E+6 because we use units, meters and Pascal. So I want to see my stresses in megapascal format, so I use E+6 format. And for displacement I want to see them in millimeters because they are small, so I use E-3 format. So that is possible because SDC uses configuration per result category. In this table you can see that we say for displacement stresses use scientific and which power to use. For the utilization factor and buckling factor we use general format, which is with 2 digits after dot. Also in our report we also have the content for loads, which shows you how your loads are combined. For example, I have all my 8 load sets and show which individual loads with what factors multiplied on what factors is included. So you have overview of your combinations in your report. Same you have for load group. You have a content where you can see which load sets are included. Now I want to also show you with plots, which has basically same idea with categories. I will generate a plot for displacement and also for stress. For now, as you can see, they are on different pages, and you can control this by using options break page before. If I set that to no, then I have my second stress plot is move to previous page, and then now I have two plots in the same page. I will make the plot looks a bit bigger to show you the difference. If you see the legend, we use same view. It is a set of options how your model will look like. I use same view for the stress plot and displacement plot, but I have different legenda. It is because SDC Verifier use the different settings for legends for different categories. For displacement, we usually use automatic legend with 12 levels, but for stress, we want to have the upper limit, so we use 120 megapascal and 12 levels. And for utilization in buckling factor, we use legend to 1.2. This is quite handy because you can use one view for different plots, same position of your model and same settings for the elements, wireframe, but different legend. For example, if now I want to show you the possibilities of the views. If I'm not happy with these views, I have created different views for my model. For example, I can update the view for the plot, and the look of my plot will change. For example, I have used elements without thickness for beams, and I think that looks better, much clearer. So what I can do, I can change the view also for displacement plot. So it is possible to control the look of your plots. Also, you can change a selection. If you don't want to select to show the full model, you can change it. I have prepared the component only with the top part. Named selection from Ansys Mechanical is available in SDC and can be used in plots, so I have top part. Okay, so and I can show only the top part in this selection. In my report, I can control which items I want to include or not include. So it's possible to exclude some part. If later I want to still generate them, I just use the checkbox item, and this part is not included anymore in my report. So I can export, and later I can include them and generate and include. So I have a possibility to configure what should be included in generation process and export by simply checking or unchecking items. So we saw some results for loads from job. For load cases, long groups, and loads, we have summary sections added by default, so that you can see that stresses and displacement can be checked in the report by default, and tables, which one the ones which was created before, I added also to report by default. Now let's focus on results for standard. Here we can see that we have characteristic. For example, we did some input for the standard, like build type, and it is possible to add in my standard description what we how we configure it. So I have defined rolled type for all my properties, and I can see that in the table it is also possible to add plot, but for this characteristic it's enough to see the table. I have added some checks in my report. Some of them I have deleted, but I want to show you that it's possible also to generate the formulas and include in your report. That's here you can see the description, the reference, and the formula. So all calculation also can be included into report. And now let's preview some results. I have here table which I have created before, and I can generate them and see that this is nice overview table to see if my check passes. If, for example, I want to have a plot, then I can create one for example, I will do for all load cases and my load group. So I can check it's possible to create not one plot but multiple plot at once. For example, I can check few views. For example, I want to have default view, detailed view, and use a view for standards. So, and SDC have created plots for different loads for different views at once, so it's quickly to generate a bunch of plots and result in report. Also, I would like to add tables for each load sets and load group. I want to add on the full model, I want to add the worst results for AISC check. So I have nine table were added to the report. So now to make this structure a bit more organized, I will sort my tables and plots and put them on chapters by loads. If you can see that for each load there was created a chapter and all the results that belongs to that load is placed under that chapter. So now I will generate one plot which gives me ideas, so I can see using this picture, because this is my envelope, that I have elements orange and red elements, the ones which do not pass the check. So for each plot we have the information table below it, so that it shows which standard and check is used, which load, the parameter on which selection, and which views. So all information about the plot is always added below the table. If you want to see, for example, we have an option in views to show only elements which are above the criteria of 1. So I will regenerate this plot and we can see element that fails according to check. In this webinar we have covered the basics of SDC Verifier, how to start in Workbench, what is job, how to do load combination, envelopes. We have checked few tables in SDC, and we did overview of a recognition tool called Beam Member Finder, which gives us a possibility to recognize beam member length, which is used in AISC standard. Then we showed how we can perform the check and how results can be shown in report. We have covered part of features of report because this is much bigger subject which can be covered in separate webinar. So we will finish this webinar. So we plan to run next webinar on plate buckling subject. So please join. Thank you for joining us for this webinar.